Day 10, the quadratic formula. Today we will be able to solve quadratic equations using the quadratic formula. So let's sing the song. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So please remember that you must have this formula memorized for your test. So if you haven't got it memorized already, please do so. Example number 1, solve the following quadratic equation. So if we have 2x squared plus 10x plus 5 equals 0, the very first thing we want to do to use the quadratic formula is make sure it's in standard form. So our quadratic is in standard form. Step number 2 is to identify our a, our b, and our c. Our a in this quadratic equation is positive 2, our b is positive 10, and our c is positive 5. Step number 3 is to plug it into the quadratic formula and simplify. X is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So you want to simplify what's underneath your radical first. So 10 squared is 100. Negative 4 times 2 is negative 8. Times 5 is negative 40. And 2 times 2 is 4. We can then simplify underneath our radical further. So we get x is equal to negative 10 plus or minus the square root of 60 over 4. We want to simplify our radical. So I know that the square root of 60 can be rewritten as the square root of 4 times the square root of 15, because 4 is the largest perfect root that goes into it. So we get x is equal to negative 10 plus or minus the square root of 4 is 2. Square root of 15 is simplified, so we can write 2 square root of 15 all over 4. After our radical is simplified, we can then make our triangle and ask ourselves, is negative 10, 2, and 4 all divisible by the same thing? Absolutely, they're all divisible by 2. So if we divide negative 10 by 2, we get x is equal to negative 5 plus or minus. 2 divided by 2 is 1. Root 15 all over 4 divided by 2 is 2. So remember, you want to write this as two separate solutions. We have negative 5 plus square root of 15 over 2, and we have negative 5 minus square root of 15 over 2. So then they ask us, how many solutions does the equation have? This equation, when simplified, has two solutions. Can we make a conjecture as to why there are this many solutions? Well, there is a positive and a minus in front of our radical, and underneath our radical we have a positive number. Therefore, we will always have two solutions. Looking at example 2, step number 1 is to get our quadratic in standard form. So we need to move our 2 to the left-hand side of our equation so that we have 2x squared minus 4x plus 2 is all set equal to 0. Once it's in standard form, we need to list our a, our b, and our c. Our a is equal to 2. Our b is equal to negative 4, and our c is equal to 2. After we've identified our variables, we can plug it into the quadratic formula. X is equal to negative b, our b is negative, so make sure you put it in parentheses, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. We then can begin simplifying. You want to simplify underneath your radical first. X is equal to, we have a negative and a negative outside here with our 4, so we can change that to a positive. Negative 4 squared is 16. Negative 4 times 2 is 8. Times 2 more is negative 16. All over 2 times 2 is 4. When we simplify what's underneath our radical, 16 minus 16 is 0. The square root of 0 is 0. So if we write that in our two cases, we have 4 plus 0 divided by 4. 4 minus 0 divided by 4. 4 plus 0 is 4. Over 4 is 1 whole. 4 minus 0 is 4. Divided by 4 is 1 whole. How many solutions does the equation have? Well, it has one solution because these are the same number. So we have one solution. And what conjecture as to why there is this many solutions can we make? Well, I noticed that there is a 0 underneath our square root. When we have a 0 underneath our square root, we will always have one solution to our quadratic, meaning that the vertex is on our x-axis. Example number 3, we're going to solve the following quadratic equation using the quadratic formula. So we need to subtract our 3x to get it in standard form. 5x squared minus 3x plus 1 equals 0. List our a, which is positive 5, our b, which is negative 3, our c, which is positive 1, and then we can plug it in. X is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Simplify underneath our radical and our negatives outside our b. So a negative and a negative make a positive 3 plus or minus the square root of 9. Negative 4 times 5 is negative 20 times 1 is negative 20. All over 2 times 5 is 10. 3 plus or minus the square root of negative 11 over 10. We ask ourselves, can we simplify our radical? So if you grab your calculator really quickly and type in square root of negative 11, what do you get? When you typed in the square root of negative 11, what did it say? Your calculator said error. Recall from a couple days ago that when we have a negative underneath the radical, we have no real solutions. So our graph is either opening up above our x-axis or opening down somewhere below our x-axis, and it will never cross our x-axis. So how many solutions does the equation have? No real solutions. And what is a conjecture we can make as to why there's this many solutions? When there is a negative underneath the radical, there will always be no real solutions. The part of the quadratic formula underneath the radical, x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a is the quadratic formula. This portion in red underneath the radical is what we call the discriminant. And from the previous examples, we learned that the discriminant tells us several things. If there is a positive under our discriminant, we will have 2 solutions. If there is a 0 underneath our discriminant, we will have 1 solution. And if there is a negative underneath our radical, we will have no real solutions. So the above example says find the value of b that makes the equation have exactly 1 solution. Well, in order to have 1 solution, what's underneath the radical has to be set equal to 0. So our b, we don't know what b is, so we can write b squared minus 4 times our a is a 3, our c is a 3, and we need this to equal 0 in order for us to have exactly 1 solution. So when we simplify, negative 4 times 3 more, we get negative 36. And to solve for what our b would equal, we can use inverse operations. So the inverse of subtraction is addition. The inverse of squaring something is square rooting it. So b is equal to plus or minus 6. You now can complete your worksheet.